Beneath the surface of our cities, beyond the view of most, lies a world built on precision, risk, and remarkable engineering. This is the story of how we construct the impossible, in water, under pressure, and often out of sight. From colossal concrete caissons to robotic arms in the deep, you're about to witness how underwater infrastructure is imagined, engineered, and made real. This is Underwater Construction Revealed. Every great city stands on invisible foundations, built where land meets water, and engineering meets the unknown. This film takes you beneath the surface, into the heart of underwater construction. From floating caissons to robotic arms in the deep, from centuries-old methods to cutting-edge innovations, you'll discover how massive structures rise from the ocean floor with unmatched precision. This is not science fiction. It's real. It's happening now. Welcome to the world of underwater infrastructure, where the future is built, one submerged foundation at a time. This is a concrete caisson, a massive, hollow structure designed to become the foundation of bridges and tunnels. Suspended by precision cranes, it's slowly lowered into position, guided by engineers both above and below. Inside, crews inspect structural details, surrounded by reinforced steel and the sound of ocean pressure. What looks like a simple descent is in fact a critical moment in permanent marine construction. Long before steel and robotics, underwater construction relied on wood, manpower, and patience. What you're seeing is a wooden cofferdam, a sealed structure placed in a riverbed to hold back water. Inside, laborers worked in dry conditions below the surface, digging by hand, often waist-deep in mud. This was the 19th century's answer to building underwater: simple materials, clever design, and relentless human effort. At the bottom of the sea, behind thick steel walls, workers stand in a pressurized chamber known as a caisson. Air is pumped in to keep water out, creating a dry space below the ocean floor where construction can continue. Every gauge, every valve, monitors pressure with life-or-death precision. It was one of the 19th century's most daring engineering breakthroughs, allowing humans to work in places nature never intended. This is how modern river crossings began, with steel piles, concrete foundations, and floating cranes. Driven deep into the riverbed, each column forms the skeleton of a future bridge. On the surface, barges and cables. Beneath, silent precision anchoring the weight of the world above. This era marked a turning point. As construction scaled up, so did our ability to connect cities across water. Today, the deep is no longer unreachable. Robotic submersibles, armed with cameras and sensors, inspect every detail of underwater foundations. Their lights pierce the ocean gloom, revealing surfaces, cracks, and bolts invisible to the human eye. Controlled from ships above, these machines are the new guardians of safety, ensuring every structure holds strong against time and tide. To build underwater, the first step is to remove the water. This is a cofferdam, a temporary steel enclosure driven into the seabed and sealed watertight. Inside, pumps remove the seawater, exposing solid ground where foundations can be safely built. It's a method rooted in history, refined by modern machinery, allowing workers to shape the ocean floor as if it were dry land. What you see here is a modern concrete caisson, a massive, pre-assembled structure engineered to become part of an underwater foundation. It's built on land, floated into position, and then carefully lowered to the seabed using precision cranes. Inside, workers inspect and prepare the chamber before submersion. Once in place, it will be sealed, filled with concrete, and locked into the ocean floor, forming a permanent anchor for infrastructure above. Beneath the waves, concrete must behave differently. This is the tremie method, where a sealed pipe allows concrete to flow directly to the seabed, undisturbed by water. The mix is carefully designed to resist separation, forming dense, stable foundations even in turbulent conditions. With precision placement and slow, steady flow, underwater concrete becomes the invisible strength holding entire structures in place. Once a structure is built, the real challenge begins, keeping it safe, underwater, and unseen. Robotic inspection vehicles, like this one, patrol submerged foundations with precision. Their high-intensity lights and sensors detect cracks, corrosion, or displacement that human eyes would miss. In the silent depths, these machines act as vigilant caretakers, ensuring underwater infrastructure remains strong, stable, and secure. Here, two worlds coexist, industry and nature, sharing the same space beneath the waves. On one side, divers and machines align steel frames with millimeter precision. On the other, marine life moves undisturbed, flowing past foundations that will soon support cities above. Modern underwater construction must do more than build. It must adapt, respect, and protect the ocean environment it enters. For those who work deep beneath the ocean, pressure isn't just a metaphor, it's a physical reality. After hours in high-pressure environments, divers must return slowly. Inside decompression chambers, their bodies adjust gradually to surface pressure, preventing life-threatening conditions like the bends. It's a quiet but critical moment, where medical science meets human endurance, protecting the people who build beneath the sea. What looks like just another road hides an extraordinary story beneath the surface. Massive concrete foundations, precisely placed in ocean depths, now support the weight of daily life above. Cars pass effortlessly, unaware of the engineering triumph that makes it all possible. This is the quiet reward of underwater construction: stability, mobility, and progress, built to last for generations. Beneath the weight of the ocean, this structure holds firm, silent, unshaken. Every joint, every bolt, every seal is designed to resist forces we can't see, but must always respect. Here, pressure becomes more than a number. It's a force that shapes design, tests material, and defines survival. In underwater construction, strength is not just built, it is proven. Long after the last weld has cooled and the final diver has surfaced, these structures remain, standing strong against time and tide. What once was blueprint and ambition is now part of the seascape. Underwater construction isn't just about building beneath the waves, it's about reaching forward, anchoring tomorrow in the strength of today. Beneath the ocean surface, the future is already at work. Autonomous drones and underwater robots move with mechanical grace, installing massive components with surgical precision. What once took dozens of divers now takes a fleet of machines, monitored, guided, and optimized by AI. This is the new frontier of marine construction: faster, safer, and smarter. The deep sea is no longer unreachable, it's a workspace of the future. Building beneath the ocean isn't just difficult, it's extraordinary. Every bolt, every beam, every breath taken by these divers is a testament to precision, teamwork, and courage. Heavy machines adapted for deep-sea work, operated with millimetric control, all functioning as one, in a realm where mistakes are not an option. This is not just construction, it's engineering the impossible. Above, the ocean appears still, but below, a world of innovation thrives. Steel and concrete anchor our ambitions to the seafloor, an unseen legacy of engineering, built for generations. As we look to the future, one truth remains: the greatest foundations are often hidden beneath the surface.